Two trains, A and B of length L and 4L, are traveling into a tunnel of length L in parallel tracks from opposite directions with velocities 108 km per hour and 72 km per hour, respectively. If train A takes 35 seconds less time than train B. So we have two trains. Let us come to the speeds first. So we have 108 km per hour. So we know that 1 km per hour is 5 by 18 meter per second. Therefore, 108 km per hour, which is velocity of A, would be equal to 108 into 5 by 18, which is 30 meter per second. And VB will be equal to, which is given to us as 72 kilometers per hour, will be equal to 72 into 5 by 18, which is 20 meter per second. Now, since they are traveling in the opposite directions, to simplify the vector approach, I'll consider VA as positive 30 meter per second and VB as negative 20 meter per second. Is that 20? Wait, 72, 4, 4, 5, 20, 108, 6, 6, 8, 48, 4 minus 10 into 6 into 5, 30. Yeah, okay. Now let us come to the visualization of this question. Okay. So, first let us see train of length L crossing this tunnel. It is given the question that the length of this tunnel, this complete tunnel, the length of this tunnel is 60 L. Okay. And length of train A is L. So, before you go into the solution, I want you to, okay, let me just take you to the visualization and things will then become clear. See, let us familiarize ourselves with some of the very common terms or the phrases that appear in most of numericals associated with these questions, specifically with respect to motion. So we have a train approaching a tunnel or a railway station or a building or any such sort of thing. Now the train here, it starts to enter the tunnel. Okay. The train has entered completely and now the train has crossed completely. I hope you are able to visualize the difference between these four. Okay. Oh, I'm really sorry for the choice of color of this train here. If you're finding it hard to visualize, maybe you should increase your screen brightness, because everything is in dark mode here and it might be difficult to visualize, to see this in the screen. Sorry. Okay, so if this visualization part is clear, we are here talking about only two sections of this. One is starting to enter and the other is crossing completely. So out of these four diagrams, we will focus on two, which is the train starts to enter and the train has crossed completely. Okay. Now, when the train has crossed completely, okay, when the train has crossed completely, the displacement of this train is given by displacement of A, which is AB. How? Let's see. So displacement is basically the final position minus the initial position, right? So this here marks the initial position and this over here marks the final position. So this initial position can be drawn over here like this, and therefore the displacement would look like this from the initial position to the final position, right? I hope that, well, actually the other way around. Sorry, yeah, initial to final, yes. So this is how the displacement vector would look. Putting this into scalar terms, as the train crosses completely, the displacement of this train would be SA, which is equal to AB, which is again AC plus CB. What is AC? AC is the length of the tunnel, which is 60L. What is CB? It is length of the train, which for train A is equal to L, and therefore displacement here is equal to 61L. Hope that makes sense, right? Please make sure that you draw this diagram and explain this to yourself. What is the initial position? What is the final position? Therefore, what could be the displacement? What are the two parts of the displacement? Okay, do that on your own. And now before you go to the next part, before you go to the the solution with train B, I would suggest you draw the same with reference to train B. Draw the initial position, final position, and try to find out what it is numerically, right? Now, when train B has crossed completely, what we see here is this. Okay. That's something else that we need to add to our train A. Displacement here is equal to 61L. We just found it out. Now, the time taken by train A to travel from A to B is TA, and velocity is plus 30. How do we connect these three? We can say that time taken by A is equal to displacement of A by velocity of A, which is equal to 61L divided by VA, that is plus 30. Alright. Coming to train B. Now the only difference here is that train B is approaching from the left and is moving towards the right. Therefore, it will enter the tunnel at C and will leave the tunnel at A. Therefore, the displacement of this train B would be CD. Now, this is where the previous diagram, the one I told you to draw, will comes into picture. Okay. So, what is CA? We know is length of the tunnel, which is 60L. What is AD? It is length of the train, which is 4L, according to the question. So, displacement of, this should not be A, this should be displacement of what? Displacement of train B, which is 64L, right? Now, we again have displacement of train is 64L, time taken by the train B is TB, velocity is minus 20. How can you connect these three? It would be with the equation velocity time is equal to displacement by velocity, and therefore is equal to 64L by minus 20. Now, according to the question, train A takes 35 seconds less than train B, which means I can say that time taken by train B is greater, which is 64L by minus 20. Train takes 35 seconds less. Train A time is 61L by 30. And since A is 35 less than B, A is 35 less than B, it otherwise means that B minus A should be equal to 35. Right? So TB minus TA is equal to 35. We will plug in TB and TA. What do we get? So we get 64L by 20 minus 61L by 30 is equal to 35. And to equate the denominators, I multiply them with 30 in the first fraction and 20 in the second fraction. And therefore, what we get is 35 into 30 into 20 is equal to 700L, and therefore L is equal to 35 into 20 into 30 by 700. So let me just confirm the calculations here as well. So yes, 64 into 3 is 64 into 3, 4 these are 12, so 18 plus 1 and 192. Yes, 64 into 12 is 1220. Okay, that's correct. So what we have here is 0, 0, 0, 0, 35 to 70, 17 to, okay, 70 by 70 is 1, so all you have is 30, L is equal to 30, yes, so that's correct. Now, this L represents the length of train A, and what are we asked to find out? The complete length of the tunnel, which is capital L, given to us as 60 times L, and therefore equal to 60 into 30, 1800. Therefore, the correct option here would be option C, 1800 meters. Okay. Very simple question. But these are the kind of questions which, which would demand your visualization to be precise. And that kind of precision comes only with rigorous practice. Okay. So yes, so the next time you see a very similar question, then you don't need to draw these diagrams in detail. You know that the visualization has already been done, and this displacement, the initial and the final position relationship drawn in picture should come into your mind at that instant. All right. Now, having said that, let's move on to the next question. Okay, now see, this is one question where I would say you need to do you need to be very clear of what the what the question is demanding in particular. You have to be able to solve this in multiple frames, and I'll try my best to solve this in two or three possible frames. Let's see.